So here are my tips to you. Don't forget to plug the first variable back in to find the other one. So you need to have two answers. I'm going to leave you guys space on your test to write your answers as x comma y. Remember that x needs to go first. And if you're going to get no solution, if that's going to be your answer, that means you have an equation left that looks like this. 0 equals 2. 0 does not equal 2. Notice how in both of these, the variables, actually I'm going to say no variables. So there's no variables left. Okay? And if it's not true, that's no solution. If it is true, that's infinite. And then the last thing that you should know by now, but some of us forget, is that slope is rise over run. Okay? So let's talk about the graphing problems. On this first one, we have y equals 2/3 x minus 2. I'm going to go ahead and zoom in a little bit because this is kind of hard to see. There we go. So 2/3 x minus 2. The last number tells you where to start on the y-axis. That's a -2. So I'm going to put a point at -2. And then it says, or has a slope of 2/3. This means that you are going to go up 2 over 3. Up 2 over 3. And I'm going to do that all the way across my graph. I can also go down 2 if I go left 3. So I'm switching both directions here. Instead of going up to right 3, going down to left 3. If you're going to go down, or if you're going to go left instead of right, you have to switch both directions. And here is my first line. Then the whole point of this is that we graph both lines and we look at where they cross. So next, this one's going to start at 3. And it has a slope of negative. There's no number there. If you want, you could put a -1, or even go as far as putting a -1 over 1. What that means is that you are going to go down 1, right 1. A negative changes whether you go up or down, not left or right. So I'm going down 1, right 1. If I wanted to go the opposite direction, instead of going down right, I could go up left. Like that. See how it still makes the same line? And then I'm going to draw my line through these. And you'll notice I had the same point on here twice. That's this point right here where they cross. And that is over 3 up 0. So my final answer for this one would be 3, 0. Let's do the next one. This one is slightly different because this one is y equals, but this one isn't. So we're going to have to talk about what to do with that. So the first one starts at 1 because there's a 1 at the end. The number in front of x is always your slope. Since it's negative, that means we're going to go down and to the right. So down 1, right 2. Down 1, right 2. Up 1, left 2. That. And I'm going to draw my line. Notice how all of my lines are going all the way across the graph. And then I'm going to draw the other line. This one's a little tricky sometimes because you have to do a little bit of work. And what we're going to do is cover up the y's, and we have 3x equals -6. I'm going to go ahead and write that down over here just because it's easy to forget. So that way, if you have your work over to the side, you won't forget. Then we divide by 3, and x equals -2. That means we're going to go to -2 on the x and put a point. Then I'm going to do the same thing for y. So I cover up the x's and I have 2y equals -6. Divide by 2, y equals -3. So that means I'm going to put a point on y at -3. Okay, and then I'm going to draw a line through these 2 points, like this. And look at that, they cross right here at -4, 3. One thing I want to say as a reminder before we move on is that there is a no solution possibility with lines, and that it looks like this. 2 parallel lines that never cross. There is also an infinite solution possibility, and that is if you have one line like this, and then you have another line on top of it. But you look, it looks like one line because there's 2 lines on top of each other. Now let's talk about some word problems. So for the graphing word problems, follow the problem just like normal. Okay, I'm going to do Penny's line first. So it says Penny has $75. So I'm going to put a point at 75 right here. And I know these lines are a little fuzzy, hard to read. And then it says she saves $25 per week. That means she's adding $25 into this account per week. So this is going to be our money because it's $75. And this is going to be the number of weeks because it's every week. So after week 1, we're going to go up $25. So she had 75. After 1 week, she'll have 100. So we're going to go to 100 and over 1. And that's a slope of up 1 over 1. So I'm just going to keep that going all the way across my graph. And I'm going to draw a line through that and label this P for Penny. Mila doesn't have any money to start with, so she's going to start at 0. And then she saves $50 per week. So I'm going to go up to 50 over 1, because now she has $50 after 1 week. That means she has a slope of up 2 over 1. So I'm going to keep going up 2 over 1. So basically, I'm doing mental math to figure out my first week, where that should be, and then I'm counting my slope so I can keep it going. And this line, I'm going to label M for Mila. Now we're going to fill in the blanks. After blank weeks, they will both have blank dollars. Figure out where they cross, because it says with the solution. The solution is right here where these 2 lines cross over each other. So that's at 3, 150. So it's 3 weeks. They both have $150. Then it says who has more money after 6 weeks and by how much. So I'm going to come over here to 6 and I'm going to look up. Okay, so Penny is at 225. And we're going to have to do a little bit of mental math here because Mila's line isn't quite there. She's at 250 and she's going up 2 over 1. So she would go up 2 more spaces over 1. Well, 2 more spaces is going to take me to 275 and then 300. So she has $300. And on the test, I'll make sure that these both fit on the graph for you. But what's the difference between these 2 numbers? 75. So Mila has more by $75. You can also figure it out by taking 25 times 6 plus 75, the one that Penny started with, and then she's adding 25 6 times. And you could do Mila's by doing 50 times 6, because she starts with 0 and adds 50 6 times. Or you can use the graph. The whole point is that you can use the graph, but I know I made that answer kind of far off the graph this time. Right. Let's go ahead and flip. I know that there was one part I haven't filled in yet. I'm actually going to do it last. Okay, so now we need to talk about the ones we do without a graph. Okay, so over here with substitution, you're always going to look for the variable that's all by itself. And then you're going to take this and plug it in for this variable. So that's y. It's going to go right here. So it'll be 8x minus 3, and then you replace y with 2x plus 3. And then you're going to distribute like that. So I just changed this part right here. Negative 3 times 2x is negative 6x. Negative 3 times 3 is 9. Then we're going to combine like terms. 8 minus 6 is 2. And I'm going to solve this like a regular two-step equation. Add the 9 to the other side because it's minus 9. And we always want to do the opposite. Negative 1 plus 9 is 8. Then we divide by 2 on both sides. And x equals 8 divided by 2, 4. Don't forget to take this and plug it back in. On substitution, the easiest place to plug it back in is the part that we circled. So that will now be y equals 2 times 4 plus 3. And 2 times 4 is 8, plus 3 is 11. So y equals 11. And then on the test, I'm going to have you guys write your answers like this. X first, then y. All right, coming over here, x equals 3y plus 4. So this time, x is the one that's all by itself. So you're going to take this and replace it with the x. So that'll be 2 parentheses 3y plus 4. So the x gets replaced with this. Notice how the x isn't there anymore. That's the whole point. And then we have to rewrite the rest of the equation. Now we're going to distribute. 2 times 3y is 6y. 2 times 4 is 8. And then we need to combine our like terms. But 6y minus 6y, that's 0. So those go away and we have no variables left. So this is where we have to decide, does 8 equal 10? No, those aren't the same number. So this is a no solution. And our last one, the top equation is y equals. So we're going to take this and plug it in for y, which will be 12x minus 4. And then instead of y, you're going to put parentheses 3x minus 2 equals 8. Next step is to distribute. Negative 4 times 3x is negative 12x. Negative 4 times negative 2 is 8. And then you have to fill in the 12x from out front, and the equals 8 at the end. Then we're going to combine our like terms. 12x minus 12x is 0, which means all we have left is 8 equals 8. That's true, so we have infinite solutions. All right, now let's talk about elimination. You guys have absolutely killed elimination if you've been paying attention. I'm not saying that none of us haven't struggled with it, but you guys have been doing really well if you've been listening to me. So, what you're going to do when you're eliminating is you're going to look at the variables and you want to look at the numbers out front. Look at the bigger one to start with, the one with a bigger value, not necessarily positive or negative. This one has a -4, so we want this to become +4 so that they add to 0. So all you have to ask yourself is what do you multiply this by so that it becomes 4x, because that's what you want. And 2 times 2 is 4. That means we have to take this whole equation times 2. So -5y times 2 is -10y, and 10 times 2 is 20. Make sure you multiply all of these numbers by 2 in the top equation. Then I'm going to lightly cross it out. We're not like making it so we can never read it again. And then you add them together. -4 plus 4 is 0. That is the whole point of elimination. 3 minus 10 is -7. And 8 plus 20 is 28. Don't forget to add these last two together. That's probably been the number one mistake I've seen on homework so far. And now we can divide by -7 on both sides. 28 divided by -7 is -4. And we have our first variable. You do need to take this and plug it back in. I don't care whether you plug it back in here or here. We already crossed that one out, so it is a little hard to read. So I'm going to plug it into the bottom one. And make sure you replace it with y, because it's what y equals. So I'm replacing this y with the -4. Well, 3 times -4 is actually -12. So I'm going to cross that out and write -12. And then we have to solve this two-step equation. In order to get rid of this -12, I need to add 12. These cancel. And I have -4x equals 8 plus 12, 20. And then all I have to do is divide by the -4 on both sides. And then on the test, I will have you guys write your answer like this. X first, then Y. And then over here, we're going to look at these x's. If this is 4x, you would want this to be -4x. But that doesn't work. There's nothing to multiply 3 by to get -4. So you're going to focus on the y's instead. Since this is 2y, we want this to turn into -2y. And the only way to make that happen is to multiply by -2. Okay, 3 times -2 is -6x, and 5 times -2 is -10. And then we're going to add the bottom two equations together. So 4 minus 6 is -2, x. 2y minus 2y is 0. Again, that's the point of elimination. And 14 minus 10 is 4. And then I'm going to divide by -2 on both sides. X equals -2. That's the first part of my answer. And then I plug that back in. I'm actually going to plug it into the top one because I think it has smaller numbers, which is easier to work with. So I'm replacing the x with -2. Then 3 times -2 is -6. And to get rid of that -6, we add 6. And then you don't have to divide by anything because there's no number in front of y. So your final answer is -211. And then we're going to do one special case at the very end. Here I want to cancel out my x's. Since this is 6x, I want this to turn into -6x. So you have to ask yourself, what do you multiply 2 by to get to -6? Well, that's -3. 5 times -3 is -15. And 3 times -3 is -9. And when I go to add these together, I get 0, 0, and -7. That is not true, so this is a no solution. If both sides had been 0, I would put infinite solutions. Okay, last thing we're going to talk about is on the front side again, and that is the elimination, graphing, and substitution. Use elimination when both equations are like this. Something times x plus something times y equals something. So x plus y equals this. Okay, here's what I mean by that. On elimination on the back side, they were all x, y equals something. X, y equals something. Okay? For graphing, even though they don't have to be, this is easiest when both equations are y equals mx plus b. Because that's how you graph lines, guys. So when it's like this, that's the easiest. You can still do it if it's like this, but that's a little bit trickier just because then this one is harder to graph. So I will ask you to graph specifically one like this, but if you have to pick, if both of them aren't y equals mx plus b, you might want to use another method. And for substitution, this is when one equation is either x equals or y equals. So when we look back at our substitution examples this way, see how this one was y equals, this one was x equals, this one was y equals. That's how you know when to use substitution. So those are the 3 things to look out for on the section where I tell you that you can use any method you want.